In this video, we're looking at example 4 in the notes for solving polynomials. And in example 4, we're given the equation, let's go into our y equals here, the equation x to the 4th minus 8x cubed plus 14x squared plus 16x minus 32. Okay, and we just have that equation, so we're going to look at the graph, zoom 6. There we go. And it's difficult to see from this picture exactly where those zeros are. So if we go to the window button, we can stretch out this axis a little bit more clearly. So I'm going to go from -3 to 5. 1, 2, 3, 4, 5. Let's try 6. And then let's go from -1 to 3 in the y direction. And that'll zoom in so we can see a little bit more clearly where these zeros look to be. So we can tell from this zoomed in picture that at 1, 2, 3, 4, it looks like we have a bounce there. If I press trace and type in 4 for my x, I can see I get a 0 for y. So I do in fact have a bounce here at +4. Okay, these other zeros are somewhere between 1 and 2 and -1 and -2, but I can't tell from the graph because they're not integers. Okay, if I look at my table of ordered pairs, I can arrow down here to +4 and see my y is 0 in the table of ordered pairs as well. So I'm going to use that 4 as my 0 for synthetic division. So x equals 4 with multiplicity of 2. Okay, I can see from the bounce in my graph. So with that multiplicity, I know I can use that as a divisor twice. So I'm going to put that +4 out front and then list my coefficients. 1x to the 4th, -8x cubed, 14x squared, 16x, and my constant is a -32. And I'm going to bring down my first value and multiply. 1 times 4 is 4. Add those together. -8 plus 4 is -4. Multiply. -4 times 4 is -16. Add those together. 14 plus -16 is a -2. Then multiply. -2 times 4 is -8. Add those together. 16 plus -8 is 8. Then multiply. 8 times 4 is 32. Add those together. -32 plus 32 is 0. And that is the remainder of the first division. Okay, since there's a bounce and I have multiplicity of 2, I can use that divisor again and bring down the first term. 1 times 4 is 4. -4 plus 4 is 0. 0 times 4 is 0. -2 plus 0 is -2. And then -2 times 4 is -8. 8 plus -8 is 0. And there is my remainder, my constant, my x, and my coefficient on x squared. So the completely factored form is going to be my factor of x minus 4 with multiplicity of 2. And then I have an x squared minus 2, and that's equal to 0. So I set each factor equal to 0, and I get x equals 4 with multiplicity of 2. And then when x squared minus 2 equals 0, x squared is equal to 2. I square root both sides, and x equals plus or minus the square root of 2. Okay, and those would be my my real zeros. Okay, if I want to check in the calculator that I got those irrational zeros correct, I can go to my x here and store, so second square root, I'm going to store the square root of 2 as x. Okay, and then I'm going to put that into my original polynomial here, which is, if I go to my variables, over to y variables, remember we have that stored as y1. So I'm going to take y1 and I'm going to evaluate that with an x. And so y1, they substitute in the square root of 2. Everywhere I see an x, I get back 0, and that's what I needed it to be, and so I know that that is a 0 of my polynomial. I can also check negative square root of 2 by storing that value as x, then arrow up to my y1 of x, press enter, and again I get a 0, so I know that checks. Okay, then if I wanted to check the 4, right, I could store the 4 as x, arrow up, get my y1 of x, and again I get a 0, so it checks. And that brings us to the secret question for this lesson. You're going to factor the polynomial that you see here completely and solve for x. And you're going to need to use graphing technology to take a look at the graph and find some integer zeros to use to get started with your synthetic division. Work your way down to a quadratic quotient, and then you can factor completely, or if that's not possible, solve for x by using the quadratic formula or another method. Okay, you have to show your work to get credit for the answers that you give. Make sure that you upload an image that includes your work and your solutions, that it's legible, and that'll be the last page when you upload your notes to Schoology.